Hello students, welcome. Previously, lesson 4, form 4 topic 6, we were dealing with the first part of alkanoic acid or carboxylic acids, where we have done the nomenclature of alkanoic acids and also the laboratory preparation of alkanoic acids. So today, lesson 5, we want to proceed to the second part of the alkanoic acids or carboxylic acids. And in this lesson, we are going to do number 1, the physical properties of alkanoic acids. Number 2, the chemical properties of alkanoic acids. Number 3, the uses of alkanoic acids. Then number 4, we are going to conclude with 4 extended questions. So kindly stay with us until the end of the video. So to start with the first part of our class today, that's the physical properties of alkanoic acids. We are going to use this table where we are having the name of the alkanoic acid, the state at room temperature, the solubility of the acid, the melting and the boiling points of the acids. So kindly have a look at the table. So number 1, we are going to start with solubility of alkanoic acids. And we are saying alkanoic acids are soluble in water. The reason is that we are saying this is because alkanoic acids are polyorganic compounds, hence form hydrogen bonding with water molecules. So next we are saying the solubility of alkanoic acids decreases along the series or down the series, and this is due to the increase in the molecular mass as the number of carbon atoms increases along the series. So example, we are saying methanoic acid is more soluble than hexanoic acid, and the reason is that methanoic acid has less number of carbon atoms compared to hexanoic acid. Next, number 2, let's proceed to melting and boiling points of alkanoic acid. And we are saying the melting and the boiling points of alkanoic acids increases along the series. And the reason is we are saying this due to the increase in the number of carbon atoms, which increases the strength of the intermolecular forces of attraction holding alkanoic acid molecules together. So next again we are saying alkanoic acids have higher melting and boiling points than their corresponding alkanols with the same number of carbon atoms or same molecular mass. And this is because alkanoic acids form more hydrogen bonds per molecule than the corresponding alkanols. That's the reason why alkanoic acids have higher melting point and boiling points than their corresponding alkanols. Like for example, what we are saying here is that methanoic acid is having high melting and boiling point compared to methanol. That's what we are saying. So next we are going to go to the second part of our class, that's the chemical properties of alkanoic acids. And we are saying alkanoic acids are weak acids, hence they partially dissociate in water to form alkane with ion and hydrogen ion. Remember we said weak acids are acids that partially dissociate in water producing few hydrogen ions. So the general question is that if we are having alkanoic acid, it dissociates producing alkane with ion and also hydrogen ion. So we know the formula for alkanoic acid, it is CnH2n plus 1 COOH, which is solution. When it dissociates, it is going to remove only that hydrogen. So what we are going to have there will be alkane with ion. So alkane with ion is having a general formula of CnH2n plus 1 COO, and it is negatively charged an ion, plus hydrogen ion, which is aqueous. So I say an example. Ethanoic acid partially dissociates in water to form ethane with ion and also hydrogen ion. Remember, ethanoic acid is acid, or in general, alkanoic acids are acids. And we said all acids, they have hydrogen ion. So that means, for example, if we go back to the mineral acids, we were having hydrochloric acid. So when we are talking about hydrochloric acid dissociating in water, we are forming hydrogen ion and also chloride ion. If we talk about maybe nitric 5 acid, we have HNO3. When it dissociates in water, you are forming hydrogen ion and also nitrate radical or nitrate ion. So if we're having maybe sulfuric acid, which is written H2SO4, when it dissociates, we produce two hydrogen ions and also sulfate radical or sulfate ion. What does this mean? This means that all acids they have hydrogen ions as the only positively charged ions. So such like that, even alkanoic acids they are going to have hydrogen ion. For example, the general formula for alkanoic acid is like this. So when it dissociates, it just puts this hydrogen aside, the remaining will give you alkanoid ion. So that means alkanoic acid behaves like hydrochloric acid when you are writing chemical reactions or chemical equations, or like nitric 5 acid, because hydrochloric acid and nitric 5 acid, especially nitric 5 acid, they are having hydrogen ion and also a radical, that's a nitrate radical. So when we're talking about alkanoic acid, they're having hydrogen ion and also alkanoid ion, which is a radical. What have we said about a radical? We said a group of atoms with a net charge. So here we're having carbon, hydrogen, and oxygen. So that's a group of atoms with a net charge. The net charge is the negative that you can see there. So that means when you're writing chemical equation, you assume that you are talking about hydrochloric acid or nitric 5 acid. They are going to have the same chemical equations or balancing as that of alkanoic acid. That means alkanoic acid will be going to have the same balancing or writing chemical equation like nitric 5 acid and hydrochloric acid. So we go part A, we are told reaction of alkanoic acids with metals. So I said alkanoic acids reacts with metals to form salt to hydrogen gas. The general equation will be alkanoic acid plus metal. We are going to get salt and hydrogen gas. So the name of the salt is metal alkanoate. So we go to examples. Number one, we are having ethanoic acid plus sodium. What we are going to get is sodium ethanoate and also hydrogen gas. So how are we going to write this equation? So first of all, ethanoic acid is written CH3COOH solution. How will you get this? By just using the general formula for alkanoic acid. Then remember we're having ethanoic acid, that is F. So we say 2 minus 1. We are going to get 1. So you take that one and you substitute in the general formula for alkanoic acid. We are going to get CH3COOH solution. We are going to have here sodium solid. What we are going to get is sodium ethanoate. So how are we going to write this sodium ethanoate? What you are supposed to know is that when you are having ethanoic acid, this acid, when it dissociates, it produces or it forms ethanoate ion and also hydrogen ion. So both ethanoate ion and hydrogen ion are having a balance of 1 and 1. So what will happen is that sodium will displace the hydrogen from the acid. So hydrogen gas will be formed, which is there. Then that means ethanoate ion is having a valence of 1 and sodium is having a valence of 1. So when they combine, we are going to have sodium ethanoate, written like this. So to balance this equation, because we are having two hydrogen here, so I have to put 2 here. When I put 2 here, I have to put 2 here. When I put 2 here, I have to put 2 here because I'm going to have 2 sodium atoms there. So, or what you're supposed to know is that you just write sodium reacting with hydrochloric acid, because the way we said this alkanoic acids behaves like hydrochloric acid and nitric 5 acid. So what we are going to get is sodium chloride plus hydrogen gas. Then try to balance this equation on your own. We're having 2 atoms of hydrogen here. So I have to put the 2 here in the hydrochloric acid or the acid side. When you do like that, check we're having 2 chlorine. We're having 2 chlorine here. So I have only 1 chlorine here. So I have to put another 2 here. When I put 2 there, that means I'm going to have 2 sodium again, but here I have 1 sodium. So that means I have to put 2 sodium side. So this is how we balance the reaction between sodium and also hydrochloric acid. So we get sodium chloride and hydrogen gas. So the way you balance this is the way you balance this equation. What will you do? You put 2 in the sodium, you put 2 in the acid, you put 2 in the salt side, then you leave the hydrogen gas like that. Example number 2, we are having propanoic acid plus calcium. What we are going to get is calcium propanoate plus hydrogen gas. So propanoic acid is written C2H5COOH solution plus calcium, which is solid. What we are going to get is calcium propanoate plus hydrogen gas. Remember, propanoate ion is having a valence of 1, but calcium is having a valence of 2. That's why we are putting the propanoate ion in bracket and putting the 2. That 2 was the valence of calcium. So to balance the equation, we put 2 in the side of the acid, then we leave the reaction like that. So if you want to balance this equation, what you do is you only remember the reaction between calcium and hydrochloric acid. What we are going to get is calcium chloride. So how do you write calcium chloride? Calcium chloride is written like that, plus hydrogen gas. So check here. To balance this equation, I'm having 2 hydrogen, but you have only 1 hydrogen there. So we put 2 there. So let us check again. We're having 1 calcium, that's 1 calcium. We're having 2 chlorine here. We also have 2 chlorine there. So for us to balance this equation, we just put 2 in the side of the acid. We are putting 2 in the side of acid. The rest are balanced. So check here. Here we're having the anion side. It's having 2. So this is the anion side, propanoate ion. So we're having the 2 there. Because it's a radical, we are putting bracket. Lastly, we are having Roman 3, methanoic acid plus potassium. What we are going to get is potassium methanoate and also hydrogen gas. So how will you write? Methanoic acid is written HCOOH. We are going to react with potassium, which is K. What we are going to get is potassium methanoate plus hydrogen gas. What happened is that we have removed this hydrogen, then we have replaced it with potassium. That's the way it is written here, and hydrogen gases from there. So part B, we are going to proceed to reaction of alkanoic acids with bases, and this type of reaction is called neutralization reaction. So alkanoic acids react with bases to form salt and water. So the name of the salt is methyl alkanoate. So the general equation is alkanoic acid plus base. What we are going to get is salt and also water. Examples. So we are having ethanoic acid plus sodium hydroxide. What we are going to have there is sodium ethanoate plus water. So this is how we write ethanoic acid plus sodium hydroxide. What we are going to get is sodium ethanoate plus water. So the problem is only how to write the salt. And we said when you're talking about ethanoic acid or alkanoic acid, it is going to dissociate into 2 ions, that is alkanoate ion and also hydrogen ion, in which both are having a valence of 1 and 1. So here we're having sodium, then sodium is having a valence of 1. So when they combine, they are going to form a compound like this, sodium ethanoate plus water. So this equation is self-balanced because you just remember the reaction between hydrochloric acid plus sodium hydroxide. What we are going to get is sodium chloride plus water. Then let's try to see whether this reaction is self-balanced or needs to be balanced. So we're having 1 hydrogen here and another hydrogen here. This one will give us 2 hydrogen on the product side. So we're having 1 chlorine here and we're having 1 chlorine in sodium chloride side. We're having 1 sodium here, we're also having 1 sodium here. We're having 1 oxygen here, then we're having 1 oxygen here. So if this reaction is self-balanced, even this reaction is self-balanced, because the similarity in these 2 reactions is that when you're talking about this reaction, the mineral acid is composed of hydrogen ion and chloride ions, in which both the ions are having a valence of 1 and 1. When you're talking about alkanoic acid, it composed of alkanoate ion and hydrogen ion, in which both the alkanoate ion, which is the anion, and also the hydrogen ion, which is the cation, are having a valence of 1 and 1. Roman 2, we are having propanoic acid plus magnesium oxide. What we are going to get is magnesium propanoate. So here, this is how we write propanoic acid. We are going to react with magnesium oxide. What we are going to get is magnesium propanoate. So how do you write magnesium propanoate? You write propanoate ion, then you put 2 there because magnesium is having a valence of 2 and propanoate ion is having a valence of 1 plus water. So to balance this equation, we put 2 in the side of borobanoic acid or in the side of the acid. If you want to confirm it, you just talk about the reaction between hydrochloric acid plus magnesium oxide. You can just do that. What we are going to get there is magnesium chloride plus water. So check to balance the equation. We are having 1 hydrogen here, but we're having 2 hydrogen there. So it will force us to put 2 there. Then when you check, we're having 2 chlorine here. This is the 2 chlorine. We're having 1 magnesium. This is the 1 magnesium. 1 oxygen. That's the 1 oxygen. So the equation will be balanced by putting 2 in the side of the acid. So let's proceed to bed C, and here we're having reaction of alkanoic acids with carbonates and hydrogen carbonates. So you're saying alkanoic acids react with carbonates to form salt, that's metal alkanoate, plus water, plus carbon dioxide. So the general equation is alkanoic acid plus carbonate, we get salt, water, and also carbon dioxide. Examples. Roman 1, we're having ethanoic acid plus potassium carbonate. What we are going to get is potassium ethanoate plus water plus carbon dioxide. So to write the chemical equation, we're having 2 moles of ethanoic acid reacting with potassium carbonate. What we are going to get is 2 moles of potassium ethanoate plus water plus carbon dioxide. The second equation, we are having methanoic acid plus magnesium carbonate. What we are going to get is magnesium methanoate plus water plus carbon dioxide. To write the reaction, we are having 2 moles of methanoic acid reacting with magnesium carbonate. What we are going to get is magnesium methanoate plus water plus carbon dioxide. So next we are saying alkanoic acids reacts with hydrogen carbonates to form salt, water, and carbon dioxide. And the question will be alkanoic acid reacting with hydrogen carbonate. What we are going to get is salt plus water plus carbon dioxide. Let's go to examples from 1. We're having ethanoic acid plus potassium hydrogen carbonates. What we are going to get is potassium ethanoate plus water plus carbon dioxide. As to write the reaction, we are going to write ethanoic acid plus potassium hydrogen carbonate. What we are going to get is potassium ethanoate plus water plus carbon dioxide, and this reaction is self-balanced. So the second reaction from 2, we are going to have methanoic acid plus calcium hydrogen carbonate. What we are going to get is calcium methanoate plus water plus carbon dioxide, and the reaction will be methanoic acid reacting with calcium hydrogen carbonate. What we are going to get is calcium methanoate plus water plus carbon dioxide. So let's proceed to Roman D, and here we're having reaction of alkanoic acids with alkanols, and this type of reaction is called esterification reactions. So we're saying esterification is the process of ester formation. Then next we are saying alkanoic acids reacts with alkanols to form a group of homologous series of pleasant smelling compounds called esters and water. And we are saying this reaction takes place slowly at room temperature. Therefore, concentrated sulfuric acid is added to catalyze the reaction. So if we write the general equation, it will be like this again. The general formula for alkanol is CnH2n plus 1 OH, which is liquid, plus alkanoic acid. The general formula for alkanoic acid will be CnH2n plus 1 COOH. What we are going to get ester and also water. If you want to write the ester, what we are supposed to know is that we remove the hydrogen from the alkanoic acid side, then we also remove the hydroxide from the alkanol. Then when we write in the ester, we write by starting with alkanoic acid. That's we take all this to this side, then we bring the alkanol to this other side, and we are going to get plus water. So we're saying esters derive their names from the alkanol first, then alkanoic acids. The alkanol becomes an alkyl group, and the alkanoic acid becomes alkanoate. Hence, alkyl alkanoate will be our ester. Let's go to examples. Example 1, we are told ethanol reacts with ethanoic acid in the presence of few drops of concentrated sulfuric acid to form an ester known as ethyl ethanoate. and also water. So for us to write this equation in condensed structural formula, this is how we write ethanol plus ethanoic acid in the presence of few drops of concentrated sulfuric acid. What we are going to get is ethyl ethanate, which is our ester plus water. Why are we having ethyl ethanate? Because when we are writing the name of the ester, we start first of all the alkanol side and we change to alkyl group. So we're having ethanol, so we write ethyl. Then the second part of the name will be having the alkanoic acid, where we are going to convert alkanoic acid to alkanoate. So here we're having ethanoic acid, will be changing to ethanoate. So that means if we combine ethyl, then we combine with ethanoate, we are going to have ethyl ethanoate. So how are we going to write this product? How are we going to write the ester? What we are supposed to know is that we first of all remove the hydrogen from the ethanoic acid and we remove the hydroxyl ions from ethanol. The two, when we join them, what we are going to get is water. So we take the remaining, and when we write in ester, the formula of the ester, we start first of all writing the alkanoic acid part. We take CH3COO, we put here CH3COO. We have removed this hydrogen. We are not going to add there. So you take again this other part, that is C2H5. You don't take the OH because this OH combines with that H to form the water. So how are we going to write in open structural formula? We have explained this long time ago. So this is how we write ethanol, the open structural formula reacting with ethanoic acid. It is written like this. So we are going to have ethyl ethanoate. How are we going to write? First of all, we remove the H here from alkanoic acid and we remove the OH from the alkanol part. So when we are writing the name, the formula of the ester, we start first of all the alkanoic acid part. So we're having 2 carbon, 1 carbon, 2 carbon. So the first carbon is having 3 hydrogen. This is the 3 hydrogen. Then the second carbon is having a double bond with oxygen. That's the double bond with oxygen. Then we're having this single bond here, which we have written straight with oxygen. That's the oxygen. We are done with the first part. Check the second part. The second part here, we're having 1 carbon. That's the carbon with 2 hydrogen. That's the 2 hydrogen. Then we're having the second carbon. That's the second carbon with 3 hydrogen. And this is the 3 hydrogen plus water. And this water is coming from this hydrogen combining with this hydroxide to form water. So example 2, we are told ethanol can also react with propanoic acid to form an ester known as ethyl propanoate and also water. So this is the condensed structural formula for that reaction, and this is the open structural formula. We have explained this in lesson 3 of organic chemistry 2. You can refer to that video. So next, let's move to the third part of our class, where we are going to see the uses of the alkanoic acids. We are saying number 1, they are used as solvents. Number 2, they are used in the manufacture of drugs and chemicals. Then number 3, they are used in flavoring foods, that's ethanoic acid or vinegar. Number 4, we are saying they are used in the manufacture of synthetic fibers such as trilene, dacron, and nylon. Then number 5, we are saying they are used in preservation of food, that is benzoic acid. Lastly, let's go to the extended questions, and remember we said we are going to conclude with 4 extended questions. So this is question number 1. Kindly have a look at the flow chart. We are going to go to the questions. So we're done question number 1. We proceed. So this is question 2. Learners, that's the end of our class today. Thank you for watching.